Section 6.3, day 1. We're going to move to something brand new. It's called proving identities, but it's not going to feel brand new. If you remember back section 6.1, where we were simplifying identities, what we were doing in section 6.1 is we were taking an expression like this and just saying, what does it simplify to? Take it down as small as you possibly can. Now, here's where the difference comes in today, and it's not crazy. It actually, many people find it easier. We're going to be taking what is called an identity. It has an equal sign, and we're going to be proving that this is true. Now, this identity is not one of the ones on your unit circle identity sheet, but an identity simply means the left side is technically equal to the right side for all cases. We don't start to shove in angles. That's not what we're going to do today. What we are going to do is we are going to use the identities that we have learned the entire page to try to technically show that this side is the same as this side. Now, there's something I want you guys to look at in the PDF version of the notes in section 6.4. If you would take a moment and just scroll down at the bottom of that page, it says the thought process to solve. You will see 8 things written down. It starts with see if anything can be replaced, turn things to sine and cosine, factor, GCF, difference of squares, conjugate, common denominator, multiply by the reciprocal. In these things, in the entire chapter, those are always things that you're looking for. They are kind of your instincts, and we will start to do those right now. Now, here is what happens in a proving. What we need to do is we need to show that the left side is technically equal to the right side. What you never do is work across the equal sign. We never do something like take this right here and bring it over. We need to show that this side is technically the same as this side, so you just work on each side separately. Now, in this first example, I'm going to work on both sides. For me, I always try to choose whatever seems the easiest or obvious just to get me started. And what I'm going to do is I'm going to start with the cotangent. Yes, I know cotangent is 1 over tangent, but it also is cosine divided by sine. Now, with experience, you will know to do that. I think it also kind of comes back where if you memorize the identities, you will see that much quicker. On this side, 1 minus sine squared. The only thing I can think of is to replace this with cosine squared. What that comes from is the old cosine squared plus sine squared is equal to 1. And if you imagine taking this sine squared over, it's just rearranging this identity. It's not breaking the rules that I had just set up there. 1 minus sine squared is replaceable by cosine squared. Now watch how we are right at our finish. 1 minus sine squared is replaceable. It's equal to cosine squared. On this side over here, because everything is multiplied together, the signs actually cancel out, and cosine times cosine is cosine squared. We have just proven your first identity, that the left side is the same as the right side. Now, just some technique. What you need to do is you need to show every step. It's always going to be provable. It's never a trick question of, kidding, the sides weren't the same. They'll always be the same. You need to show every step along the way to show that the left side is the same as the right side. So the equal sign in the middle stays. You don't put an equal out front. And I would show each step underneath to show how you can prove that each side is technically the same. Now, we're going to do one more, and then we're going to stop for day 1. Don't worry, day 2 we'll do actually a lot more, and that's where your comfort level will start to rise, maybe with the entire chapter. So for the second example, let's say we had to prove that the tangent of x was technically the exact same as the cosine of 2x, that's a double angle, and then divided by the sine of 2x. That's not squared, that's not a superscript. And we have to figure out, what would this be? Is this right? And it is. They'll always be right. We have to prove that the left side is technically equal. It's identical to the other side. Now, here's where you'd have choices, and don't panic. With experience, your instincts will kick in and you'll know what to do. I'm going to leave this tangent alone. Okay? Like the previous first example, you can work on both sides, or you can work on just one side. I'm going to show you how you could work on just one side in this question. The previous one, it made sense to work on both sides. So on this side, we have to somehow show that the right side is going to end up being tangent with a little bit of work. And you always write down each step in its entirety. You repeat the tangent, you repeat the equal, and now we're going to do something. Now you might be asking yourself, well, what am I going to do? I'm going to start with a sine of 2x. If you go to your double angle identities, there is only one identity. And this is what the sine of 2x or 2a is equal to. It goes sine a or x, and then multiplied by cosine a, or in this case, x. This is the identity. That's been proven a long time ago. Now, up top, what I'm going to do is I'm going to replace the cosine of 2x with something, and you might be now frustrated yet again because when you look at your identity sheet, there are three. There's three things that mathematicians have proved cosine of 2a or 2x are equal to. And then you're like, throwing your hands up in the air saying, well, which one am I supposed to use? What I'm going to do, because this is your first time at it, you're like a rookie, is I'm just going to tell you guys how you'd make this decision. I'm going to write it down. 1 minus 2 sine squared x. Notice the difference between the squared and the 2 like that. Why would I even know to do that? Well, here's what it is. 1 subtract 1, that goes away. That's got to be going somewhere good because then we can start to cancel things out. So again, technique, you always write down every step. So I have a tangent x, and then on this side, the 1's cancel out. The subtract goes not only to the 1, but it also goes to this one, so it changes it to a positive 2, and then a sine squared, and then the denominator was a 2, and then a sine x, and then a cosine x, and we're almost there. So what we have is tangent of x is equal to, and here's what I'm going to try not to do too many steps at once. First of all, because everything is multiplied together, these 2's cancel out. Now one more, because everything is multiplied together, this sine squared, I'm going to erase and then bring it back. Don't forget what that technically means. That technically means sine times sine. Well then, one of these sines could cancel out. Here's a short version of how you can do it. You could just take the squared away, right here, and one of these away. It's really showing you have a deep understanding. And then you're left with sine over cosine. And now here's your grand finale that to somebody who's not trained in math would be like, well, that's redundant. But we know this. This side is tangent x. It's always been tangent x. This side, if you glance at your identity sheet, or hopefully not, because this is one of the ones you were supposed to memorize, sine over cosine is equal to tangent x. We have just done it. This is what proving an identity is all about. You're supposed to take an original expression, it's an identity, and it'll always work where the left side is technically equal to the right, but we need to manipulate the identities and simplify to get down to this final answer. Now, in the PDF notes, there is the assignment. It's, I believe, page 315, numbers 1 and 2. Just a note, number 1, you don't actually prove. What they get you to do is a whole bunch of factoring, so it's almost like you're only working on one side to get you practiced up. And then number 2 is when you actually do some proving. And again, the next day, section 6.3, day 2, might be where your confidence goes up. We'll be using those mythical sheets again, and I think you might start to really see the big picture.